Our topic is special glasses. Uh, a very important type of special glass is the optical glass. Optical glass includes only those glasses with high homogeneity and special composition which have definite optical characteristics. These characteristics are of such an accurate nature so as to permit their use in scientific instruments. Most important requirements of an optical glass are: first, its composition should be according to the required optical properties. That is, for what purpose the glass is going to be used. Second, the batch should produce glass of low viscosity, and viscosity should be sufficiently low. Third property is that the glass should not devitrify even upon long annealing. Fourth condition is it should produce nearly a colorless product without the use of coloring material. The glass should be free from bubbles. Glass should have advantageous grinding and polishing properties. The glass should be capable of withstanding the action of atmosphere. Optical glass is also known as the Crookes glass, and it generally contains phosphorus and lead silicate with a little bit of cerium oxide. Cerium oxide is capable of absorbing ultraviolet light. In general, optical glasses are relatively soft and they have low melting points. And the important properties of optical glass are: it has low viscosity, there is absence of bubbles, there is no devitrification on long annealing, and it has the capacity to sustain optical clarity. Optical glass is used in making optical instruments as lenses of telescopes, microscopes, etc. Borosilicate glass. Borosilicate glass is another type of special glass, and this glass is an example or type of optical glass. It contains about 13 to 28% of B2O3 and 80 to 87% of silica. It has low expansion coefficients, superior resistance to shock, high electrical resistance, and high chemical stability. The composition of a typical borosilicate glass is SiO2 is 80.5%, B2O3 13%, Al2O3 3%, K2O 3%, Na2O 0.5%. A glass of low thermal coefficient of expansion and high chemical resistance is obtained by substitution of alkali Na2O and basic alkaline earth oxides, calcium oxide of the soda lime glass by boron and aluminum oxides. These glasses are used in the manufacture of baking dishes, laboratory glassware, pipelines, insulators, and washers. Lead glass. Another type of important special glass is the lead glass. Lead glasses are obtained by mixing lead oxide, silica, and alkali with lead content as high as 92%. The important properties of lead glass are: it has high refractive index, it has low hardness, it has high dispersion power, it has high density. The density of lead glasses can be as high as 8. Lead glasses are widely used in optical work because of their high index of refraction and high dispersion. They are also used in the manufacture of electric bulbs, neon tubing, radiators because of high electrical resistance of the glass. Next type of important special glass is the glass wool. Glass wool is obtained by the action of steam jets on dripping streams of molten glass, uh, which are dripping down from small holes. The glass wool consists of innumerable tiny fine fibers which are formed in this manner is carried away by a conveyor belt on which it is hurled. Glass wool is a fibrous wool-like material, and it is composed of intermingled fine threads of filaments of glass, and it has a number of important properties. For example, glass wool is non-combustible in nature. Glass wool is fireproof. Glass wool has low electrical conductivity. Glass wool is heat proof. Glass wool does not absorb moisture or water. Glass wool is chemically resistant to a number of chemicals. Glass wool has a low density of 65 kg per cubic meter. Glass wool has low thermal conductivity. Glass wool has a high tensile strength, about 8 times that of steel. Glass wool is used for heat insulation purposes in ovens, metal pipelines, motors, vacuum cleaners, walls and roofs of houses, and in domestic appliances. Glass wool is also used in the filtration of corrosive liquids such as acids and alkalis. Because it is chemically resistant. Glass wool is also used for sound insulation purpose and used for the manufacture of fiberglass by blending with plastic resins. Photosensitive glass. Photosensitive glass is another type of special glass. This is a high alumina soda lime glass which is sensitive in ultraviolet region. It can reproduce the object in live natural colors from an ordinary black and white negative recorded in the visible region. The positive on the glass is developed by thermal treatment at 540 degrees centigrade to 550 degrees centigrade. The desired photoactivity in the ultraviolet region can be obtained by admixture of high alumina soda lime glass with small amounts of Cu2O, NaCN, SnO2 and abietic acid in appropriate amounts. Blue color is promoted by NaCN in absence of tin oxide. In presence of tin oxide, an impression in red is observed. By manipulating the ingredients in glass, brown and yellow images can also be obtained. Potash alumina glass mixed with LiSiO3, cerium and silver salts in appropriate proportions have also been used as photosensitive glass. Photochromatic glass. Another type of important special glass is the photochromatic glass. Such glasses have a large number of microscopic particles of silver halides trapped in the three-dimensional silicate network in fixed concentration. On exposure to light, temporary color centers consisting of silver particles only are produced, and these add up quickly, producing total darkness. The intensity of darkness depends upon the concentration of silver. Because the reversible darkness is controlled by the radiations in the UV region quite abundant in daylight, the photoblackening does not occur markedly in the lamplight in the night.